Okay, class. We start our lecture today. Bismillahirrahmanirrahim. Okay. Before this, we have take a look for the conditional statement. Please bear in mind the conditional statement is the compound statement. You need to uh, combine combine hypothesis and also for the conclusion. Okay. For now, how you want to create a truth table is based on 2 power of n. Power of n. N is the variable. N is the variable. Okay. Kali apa nak? Kali ni. N is the variable. Let's say you have P and Q. We have 2 here. 2 variable here. And then 2 power of 2 lah. Equivalent to 4 lah. Okay. And then we have P and Q. R. P and Q R. Suppose we have a truth table 8 lah. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay, this one is just the number of variables. And then, okay, we have P, 1, 1, and 1. And then P and Q, 1 multiplied by 1. Okay, and then multiply again by 1 is 1. Okay, tak nampak. Okay, 1. Okay, and then 1 multiplied by 0 is 0. Multiplied by 1 is 0. 0, 0. Okay. Okay, this one is for the number of variables. So far, do you have any question? Can I proceed? Boleh eh? Kan boleh belah tadi. Okay, if I can proceed, please type 1 in the chat. In the chat. Okay, this one is P and Q and R. Supposedly you need to have 8. 8 because of the 2 power of 0 is equivalent to 1, 2 power of 1 equivalent to 2, and 2 power of 2 equivalent to 4. Okay, and then here we have a true table, true, true, and true, and then repeat again, true, false, true, false, true, 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 true. Later we see this one. Okay, but most importantly, you have 2 power of n. N is the variable. How many variable? Okay, okay, this one is the P and Q and R. We have 2 power of 3. We have 2 power of 0 is 1. 2 power of 1 is 2. 2 power of 2 is 4. And then we have 2 power of 3. And then you should have 1, 2 until 8. Okay. Okay, this one simple. Okay, let's go for this one. We have a 2 power of 4. We should have 16 in the table here from 1 until 16. Okay, P is 2 power of 0, 2 power of 1 is 2, 2 power of 2 is 4, 2 power of 3 is 8. Okay, same goes here. We have to generate the truth table. Okay. Okay, let's go for the example. Maria learns discrete structure is a hypothesis. This one is conditional statement. If you look the implies, here is if then. Then, okay, Maria will find a good job. Is the conclusion hypothesis and the conclusion. Okay, okay. If Maria learn discrete structure, then she will find a good job. Okay, this one is first cases. Second one is Maria find a good job if she learns Okay, the conclusion follows by the hypothesis. This one we learned last week. Follows by the hypothesis. And then Maria learns discrete structure only if and only if she will find a good job. Okay. Okay, this one is the example. Okay, this one is important because the conditional statement should have three main uh, component. 1, 2, 3. Okay, so far, do you have any question to be asked? Is it okay? Boleh ke? Okay, jangan don't be tension because this subject you should enjoy a little bit because some of you is quite tension. Okay, we have converse, inverse, and contrapositive. Okay, first of all, given any then statement, if P then Q, we can create a three related statement. Conditional statement consists of two parts, hypothesis and if clauses and conclusion in the then clause. For instance, if it's rain, then they can sell the school. Okay, if it's rain, there is the hypothesis, and they cancel school is the conclusion. Okay, I put in the PowerPoint. If I'm too fast, you should ask question. Kalau saya laju sangat, bagi tahulah. Kalau slow sangat pun bagi tahu. Boleh ke? Okay, first one, if the conditional statement, it's rain. Okay, it's rain. Okay, sorry tulisan tak cantik. Okay, and then the other one, they cancel school. Okay, okay, this one is the conditional statement. Okay, if it's rain, is the hypothesis. This one is hypothesis. Okay, this one is conclusion. Okay, and then to form the converse, okay, and then we have a type 1. Type 1 is the converse. Interchange the hypothesis and the conclusion. Okay, we need to interchange. Okay, for the first one, it's converse. Interchange the hypothesis and conclusion. Okay. Okay, how to interchange? If it's rain, then they cancel school. If they cancel school, then it's rain. Okay, jadi dia akan jadi if they cancel. Okay. Okay. Is it okay? Do you have any questions so far? Laju sangat ke? Slow sangat ke? Boleh ke? Okay. Jangan segan. Kalau ada masalah terus tanya. Siapa yang bagi mesej banyak sangat ni? Okay, this one is for the converse. You need to interchange the hypothesis and conclusion. Just interchange the hypothesis and conclusion. Just Coordinate back the position. Coordinate back the position. Okay, this one is for the first one. Okay, saya buka lagi satu lah. Okay, the second one Second one apa tadi? What is the second one? Tak ingat lah tu, inverse. Okay, for the inverse, you need to take the negation of both of hypothesis and conclusion. You need negate negation for both hypothesis and conclusion. Okay, you need to negate You need to negate for both hypothesis and conclusion. Okay, jadi kalau if I go for negation, it should be like Ainon. Ainon boleh bantu ke? Ainon Sakina. Dia akan jadi apa? Ainun Syakina. Dia akan jadi apa? Faizul dia akan jadi apa? Tak tahu. If it does not rain, not rain. Okay. Then they do not. Okay, boleh? If it does not rain, then they do not cancel school. You just put the not not for both hypothesis and conclusion. Nabila okay, Nabila? Nabila? Oh, keluar dah. Apa? Tak apalah. Triple pun tak apa. Okay, inverse we have converse, we have inverse, and the other one kita ada apa? Okay, pandai. Siapa yang jawab tu? Oh, Syahida pandai ni Syahida. Okay, and then we have contrapositive, contrapositive, conditional statement. Okay, all of this is conditional. Please bear in mind. Contrapositive. Okay, contrapositive is interchange the hypothesis and the conclusion of the inverse statement. We interchange first. Interchange. Okay, interchange the hypothesis and conclusion. Okay, hypothesis of the inverse statement. You need to interchange first the inverse statement. First, you need to converse, and then you need to inverse first, and then you interchange. So, if it is okay, if they do not cancel school, okay, and then supposed to if they do not they do not cancel school, then it does rain. Okay, you need to interchange from the inverse statement. Okay, this one for the third one, contrapositive. If they do not cancel school, then it does rain. Okay, we interchange the hypo and conclusion of inverse statement. Okay, so far do you have any question? Amma, okay ke? Amma Ashraf? Syami, okay Syami? Janganlah marah, tanya je. Okay, seterusnya okay, this one is just the explanation back what I'm explaining. Okay, the converse of conditional statement is the form by switching the hypothesis and the conclusion. Okay, you just switch the position, switch the position. Okay, and then if I am sleeping, then I am breathing. Okay, you need to converse. If I am breathing, then I am sleeping. Okay, you just switch the position. Okay, for the inverse, a conditional statement is formed by negating. You need to put the negation. Not I am sleeping, then I am breathing. And then for the inverse, I am not sleeping, then I am not breathing. Okay, you just put not. And then for the last one is the contrapositive, is you need to form by negating the hypothesis and the conclusion of the converse. You need to converse first, and then you just I am not sleeping, I am not breathing. You just switch. Then I am not sleeping. Okay, you converse first. Okay, and then it will be the contrapositive. I am breathing, then I am sleeping. You just switch first. Okay, switch. Okay, and then you negate. I am not breathing, then I am not sleeping. Okay, this one is another example. P implies Q. I am sick, then I am not attending the class, and so on. We have to inverse and converse. Okay, and then contrapositive. Okay, same goes here. Okay, you read a letter. Okay, and then we have the conditional statement, inverse, converse, and contrapositive. All have a truth values. A truth value comprises of true and false. Please bear in mind. And then when two statements are both true or false, we can say that they are logically equivalent. Logically equivalent when they have a same output. Same output of truth value. Okay, this one you need to form a truth table first, and then you you are is assuming that they have the same truth value for all possible combination. Basically, for the truth value in the variable that appearing in the two expression that are denoted by the variable. Okay, this one you should do this one in for your own exercise, and then please upload to Padlet. Please upload to Padlet. I can see your effort. You need to inverse and then converse, and then lastly is contrapositive. You need to switch the insert not. Then insert the not. Okay, this one you need just for your own exercise. You need to upload to Padlet. Okay, as a conclusion, conditional statement and its contrapositive have some truth values. Later we discuss this one. They are both true. They are logically equivalent. Okay, logically equivalent. I have explained to you all what is logically equivalent. They have same truth value for all possible combination. This one truth value combination. Okay, for all combination of truth value for all variable in two expression. For two expression. Okay, this one is if the weather is warm, then we should go swimming. Is it a hypothesis or conclusion or neither? You should answer in the and upload to Padlet lah. Okay. Also, same goes here. If you like purple, you love this sweater. Is it the hypothesis and conclusion or neither lah? Okay. Please. Okay. Please justify the underline conditional statement only. Okay, identify the converse for the given conditional. You have two. If you like tennis, then you play on the tennis team. Okay, identify and okay, this one is the converse. Converse, what you need to do. Okay, and then choose A, B, C, or D. Okay, identify the inverse of the given conditional. If x is odd, then 2x is even. Please answer. Okay, this one is logically equivalent. We have the question both a compound proposition. Compound proposition. Last week I have explained. You need to join the proposition, proposition one and proposition two, and you need to prove the two proposition is logically equivalent. For example, you can see P negate P or negate Q is equivalent to negate open bracket P and Q is the same output. Okay. Okay. Therefore, this one as a conclusion. Therefore, P and negate Q is equivalent to negate P and Q. Okay. This we call as logically equivalent. Both column have the same truth value. Therefore, they are logically equivalent. Okay, for this one, before we can conclude that one for proposition output for one and two, we can call it as a biconditional, biconditional, and then all are true value. It is called as a tautology. Tautology. Okay, tautology. Tautology is a compound statement in math, which always true result in the truth value. You need to have the truth values, truth table first, and then when you evaluate, all of the output or result are true, and then you can say a tautology is a compound statement in the truth table that always true in the truth values. It is also doesn't matter what is the individual part consists of. The result tautology is always true. Okay, the result is always true. This one is you need to bear in mind. The opposite of tautology is contradiction, or we can call it as a fallacy, which we will learn later in a chapter 4. Okay, we have the ambiguity. Ambiguity. For now, you just bear in mind that all truth values it is a tautology. It called as a tautology. Okay, this one statement and operators. Okay, we have true and true. And then we have negate P is false, negate Q is also false because we have true is either way. And then negate P or negate Q is false. Okay, because we plus this one. Okay, 0 plus 1 is equivalent to 1, 1 plus 0 equivalent to 1, 1 plus 1 equivalent to 1 lah. Okay, is that okay? Syami, boleh ke? Hairil, Nila boleh ke? Nila, boleh ke? Okay. Felicia, is it okay? Okay. Okay, same goes here. You need to flip through for this one. Okay, we have combined in any way to form a new statement. Okay, and then here is also same. We have the tautology. Before that, you need to see this one. All the value are the same. Okay, for 1 and 2. Okay, and then we can see is 1 is a biconditional of 2 because we have the same values. And then for the output, okay, it is a tautology. It is a tautology because all of the values in the truth table, therefore 1 is equivalent to 2 lah. Okay. Okay, this one is a tautology, contradiction, and contingency. Okay, we have logically equivalent because the output of truth value for negate P and negate Q are equivalent to negate P and Q. Okay, if you have here, it's also the same. If you have the x value, if you negate the x 2 times, it's equivalent. This one is equivalent to x. Positive. Negative, negative to positive. And then the tautology, all the values are true. Are true. And then contradiction, what is contradiction? All the value are false. It contradict with the tautology. And then we have contingency, combination of true and false value. Okay, we have three here. Okay, we have a tautology. Okay, secondly we have contradiction is contradict from the tautology. And then contingency is a proposition that is neither a tautology or nor a contradiction. Uh, is no is neither a tautology nor a contradiction. Example, we have a contradiction contingency logic. This one a combination of true or combination of false. Okay, in philosophy and logic, for the contingency is status of proposition that are neither true under every possible valuation. Under every possible valuation for the tautology, depend on the tautology, no false under every possible valuation is a contradiction. Okay, and then a contingent proposition is neither necessarily true or neither necessarily false. It is a combination. For example, you have tautology, okay, true uh, and false, and then we have true or true. For this one, we can say that the contingency is a combination of true and false. Okay. If you said it is contradiction, you need to have all false value. If you said it is tautology, you need all truth values. True and true. Is it okay? Pening sikit. Dah start pening dah. Okay, we continue. Okay, little bit. Okay, this one is just combined in any way to form a new statement. Okay, please do this one. This one is the exercise. Please upload to Padlet. Padlet. Okay, do not forget to write down your names. Your names. Okay, and then okay, this one is statement. Negate P and Q, and negate P or negate Q are logically equivalent because of negate P and Q biconditional with negate P or negate Q is always true. It is tautologies. Okay, are they logically equivalent? One and two. Okay, you need to do this exercise. This also you need to upload to Padlet. Okay, so far, do you have any question before we continue to chapter 2, 1.2? Is it okay? Okay. Kalau okay, we rest for 5 minutes, 5 minutes, and then we continue to chapter 2, We rest for 5 minutes.